Okay, now let's suppose that you don't know how to compute the function. Let's suppose, for instance, that we have to compute the logarithm of a number and we don't know what is the function. So there are two options here. The option that I suggest you, is to open a web browser and then you go to Google and then you look for logarithm and R project. And you have to write R project, not only R. And you see that the first link is logarithms and exponentials. Okay, let's go into it. And you see here usage. Log. Log, between parentheses, you see two arguments. The argument of the logarithm, x, and then base equal to. Okay, base, it means that you can change the base of the logarithm. So we can write base equal 10 or base equal exponential of 1, which is base e. Okay, fine. So let me try to compute it. Log 10 to 30. If I make log 10 base equal 10, I expect 1, perfect. If I compute log exp 1, I expect 1, perfect. So you look at a web browser for the operation that you want to compute, you look into Google and you find the help. Another possibility is to write help logarithm in R. If we do like that, it doesn't find it, and therefore it says no documentation for logarithm. You could try double question mark logarithm. So let's try double question mark. I clear the screen. One important thing, if I want to recall the previous instruction that I gave, if I use arrow up, it goes back. It remembers everything we did. You see, I'm scrolling back. It remembers everything, which is a good thing. On the other hand, remember that you cannot undo. Okay? So whatever you do, you cannot undo in R. Okay, so let's add the second question mark. You see, I recalled the previous instruction, and then I added the question mark. I could have written from scratch again by spending some 10 seconds more. And you may think you are obsessed by time, but indeed I tell you I'm not. I directly experienced it, that if you save 10 seconds 10 times, 100 times a day, at the end of the day you feel more relaxed. So if you can save 3 seconds, just wonder how you can do it. Time is one of your best values, I tell you. And when you go for an interview, you look for a job, if people understand that you are efficient and rigorous, this is what they look for. Efficiency and rigorousness. So you are able to perform tasks fast and well. Fast and well can go together. We have a proverb in Italy that says presto e bene non stanno insieme. So fast and well, they cannot be joined together. It's not true. You can do things well and fast. Tell you. Believe to me. Okay, so double question mark logarithm, it takes some time. Probably doesn't find any useful information. In my experience, this way of looking for help is less efficient. I prefer to go on the web and look on Google. And you see that here there is something. It says logarithm and exponential, and log that extracts the logarithm of the determinant. So we could get the information in the same way, but I think a web browser, Google, is more efficient in getting to you directly where you want directly where the information is. Okay, so there are several functions, and my suggestion is let's wait for the need of them to learn them. At the end of today, I will propose you an exercise, computation of a flow duration curve. We will need to learn some functions, and we learn step by step. Okay. Second thing, let's learn how to use vectors, because so far we dealt with variables that were directly, not variables, numbers that were directly inputted, given an input to the program from the keyboard. Now let's work with a vector. And vectors are defined in this way through a function, and the function is called C. And the function allows you to specify a vector. The elements of the vectors are to be separated by commas. And if you just press enter, the program gives to you back the vector itself. Like when I press 2, it gives back to me the number. Now, we can work with functions on the vectors. So, if I do sqrt of c, 4, 16, and 9, what you get is the computation of the square root for each element of the vector. If we do the sum of two vectors, plus c1, 1, 1, what would you expect? It sums element of the vector one by one. If the length of the vectors is different, because you make a mistake, you get a warning. And what it did, basically, in this case, first of all, it gives to you a warning. It gives the length, longer object length is not a multiplier of shorter object length. And what it did, because this is a warning, it's not an error, it gave a result, which is this one. How was this result computed? It was computed by repeating in the shorter vector the first element. So he transformed the vector 2, 3, 4 into 2, 3, 4, 2. And then it summed 1, 1, 1, 1, getting 3, 4, 5, 3. So you have to learn how it works. In general, when you get warnings, be very careful, because it means that something is maybe missed from your side. Okay, now let's learn how to use variables, because it is essential. We can define variables. I'm clearing the screen. If I say equal 10, and then I type a, then I get 10. This is a way of defining variables. If b is equal to 5, I can compute a plus b. And I can also compute the square root of a plus b. The same thing with vectors. I can write a equals c, 1, 2, 3. And then I can write b equals c, like 3, 3, 3, a plus b. So you can memorize vectors, you can work with vectors. And now we are at a crucial point. If I can memorize something, it means that I have to save something. Okay? Very good. So, I suggest you to save, frequently save, because it protects you from crashes of the PC, etc. And also there is one thing that you have to take into account. Given that you cannot undo in R, it is important that you save frequently, because you can get back to the previous stage if you made something wrong. Okay, there are two things that can be saved. Two things that compose the workspace. And these things are the data and the history. The history is the collection of all the previous commands, the ones that you get back with the up arrow, with the arrow up, these commands. The fact that you can save the history, it is a huge opportunity, because it means that you can repeat whatever you did in 1 second by just recalling the previous history. So you cannot undo, but if you make a mistake, and you can, thanks to the history, get back to the previous stage anyway. Do you understand? Meaning that with the previous history, you can redo everything you did from the beginning of your work session. So if you cannot undo the previous, for instance, if you make a mistake and you cannot undo it, through the history, you can anyway get back to the previous step. And keep in mind that the history can be reloaded with just one instruction. So this is why there is no undo, because there is the history. So how can we save it? There is a very quick way of saving, and this is the way that I use, currently I use, which is exiting from the program. Exiting from the program via the instruction Q. Now, if you press enter, Q with 2 parentheses because it's a function, the question is printed on the screen, save workspace image. If I press yes, I get back to my console. If I restart R and I go with the arrow up, there is my previous history. So this is a way of saving when you exit. And also there are the variables. You remember I defined a vector A, it's still there. Don't forget when you exit to press yes at the question, would you like to save the workspace? If you press no, everything is lost and there is no way to get it back. Also, I tell you one thing, if you write Ctrl+C in R because you want to stop a job, for instance, it is a disaster because Ctrl+C in R, no, in this case it didn't bring me out. There is basically, let me see, okay, in this case it didn't give me the problem. There are some platforms where Ctrl+C closes R without saving, so you have to be careful. Maybe it's Ctrl+Q, no, okay. It seems that maybe in the new version they fixed it, because experienced users, usually they stop jobs with Ctrl+C if there is no other way, and Ctrl+C it's a bit dangerous. But forget about it because it seems that it doesn't go out. Okay, so the next question is there a way to save without exiting from the program? Yes, there is a way. And I think it is, I don't remember the instruction, I think it is save image. How to check whether it is save image, what I'm looking for. I start writing it, and then with the tab function, I check if there is a way to complete the instruction. The tab is a way to complete the instruction in R. And you see that there are no other alternatives. In the same way, if I want to write square root, with the tab I can complete it, saving 2-3 seconds. Okay, save image, this is the function. And you see, in this case I found, without the dot, with the save, just save, I found all the alternatives. The tab, when there is there is more than one alternative, the tab lists to you all the alternatives. And you see that there is save history. By the way, save history, it reminds me that probably there is the instruction also to save the history. And save image, save RDS, I don't know what is. Okay, let's try with save image. And now, let's see whether it saved it. So, let's go out without saving. No. Let me restart it again. And let's see whether in the history there is save history. No, it's not there. So save image didn't save the history. Probably save image only saves the data. Let's try to make an experiment. Like, let's define a new variable, d equal 1. Okay, now let's go with save image. Sorry, I made a mistake. Okay, let's try to go out without saving. I restart again, and let me see whether there is the, yes. So save image only saves the data, not the history. But I noticed before that there is a command called save history. So let me try to recall it. And in this way I save the history. I think there is also the way to save everything, with only one command, but I leave this to you to explore. Okay, so now we are able to deal with variables, vectors, we are able to save. Before we start, we are almost ready to start with an exercise. Because the first exercise is to compute a flow duration curve, which is very easy. We just need to know the names of a few functions. We are almost ready to go. Before I go with the exercise, let's explore another function which is extremely important, and I give to you as an homework the task of trying to use it and explore the several possibilities of the plot function. Let's define, we have some vectors. First of all, if you want to list the variables and vectors that we defined, the instruction is ls. We define the three vectors, a, b, and d. Okay, let's try to write plot A, just plot A. Let's see what happens. So, another window is open with a graph. The graph is very rough, very underlocked. It displays index on the abscissa. What is index? It's the index of the vector 1, 2, 3. Okay, here it is displayed with decimals, with digits, which is not appropriate. But of course, plot interpreted the index as a real variable. And then the values of A. You see on the Y, A. And you have 3 dots. With R, you can make very sophisticated plots, and they are much more sophisticated with respect to Excel plots. And therefore, I think it is very important for you to learn how to create sophisticated plots. It is important because the plots that are made in Excel, they have the advantage that it's very quick to use. So when I have to print a plot very quickly, I use Excel. Because if I have just 10 numbers to plot, like in this case, I'm not opening R, and because you see that the graph is very undeveloped, and to further develop it, it requires some time. Excel has some templates for creating graphs, so it's much easier. But there is, of course, the counterpart. The counterpart is that you can only use the templates in Excel that are suggested by Excel itself. You cannot make personal changes to the templates. For instance, in Excel, if you want to put the labels of the axis not equally spaced, you can't do it. So if I want to put labels at 1, 10, and 20 in Excel, it's not possible. You have to use 0, 10, and 20. You cannot start with the label that you choose. In R, this is possible. And therefore, again, I think it is extremely important for you that you learn how to draw very developed graphs. In your profession, you are an engineer, you will have to print out several graphs. Some of them will be standard. In some cases, you may be required to use no standard graphs. And what a professional usually does is, in these cases, to give an external task, to give the task to an external worker, which costs money and takes time. If you can yourself design very, let's say, elaborated graphs, this is something that is really useful to you. We will not really learn this during this course because we don't have time. But I highly suggest you to explore this opportunity. And I just give you an example of a graph that I did with R in order to show you something that you cannot do in Excel. And just 1 second. Let me see. One first example is this one. This is the time series of the Po River flows from 1920 to today. And this is an animated graph that shows for each year the amount of the river flow. And this kind of animation, of course, cannot be done in Excel. You can do it in Photoshop if you are an experienced user. In R, it's very easy. And the red line is the overall average or mean. And this allows us to see the progress of the time series year by year. This is one example. Another example is this one. This is a representation on a 3D of the same time series. This is very elaborated, but it's not very difficult to do it in R. Let me see if I can get it working, because it's a bit heavy. And let me see if it starts. You see that it is automatically rotating, and the time series is displayed in this way. These are the years, these are the days, and then the river flow is in vertical here. And it's slow because I don't understand why. When I connect the external monitor, it becomes the visualization becomes slower and slower. Anyway, another. So this is done with the function plot of R. Okay. Let's forget about plot for now, because we will get it back when we have to draw our flow direction curve. Okay, so now my proposal is to get the first exercise that we have to develop together. Because, as I said, I want to start from the technical exercise and learn by doing. I suggest to learn by doing, not to learn through the top-down approach. So let me go to my website, where you will find there that there is an exercise available here. So here you can see the short introduction to R and RStudio, and the first exercise, estimation of the flow duration curve, and there is a suggested R file. Let's forget about the suggested R file for now. Let's download the exercise, estimation of the flow duration curve. It is a zip file, and if you get to the zip file, you see that there are 2 files into it, and one file is a PDF. Let's open the PDF. One note, I'm not sure whether I am going too fast or too slow. Just let me know. If it is too fast, absolutely you have to let me know. And either individually or collectively. So just stop me if I'm going too fast. If I'm going too slow, in the same way, please tell me, because I didn't check whether you can. There are some of you maybe that already used R. I didn't check it because I want to start all together from scratch. But if I'm going too slow, just tell me. Okay. So the exercise is the one that you can see here at the river cross-section of the Po River at Ponte Lago Scuro. Ponte Lago Scuro is the closure of the Po River catchment. Closure means the point where, by convention, we assume that the river ends and the sea begins. It's before the delta. So, at the closure, we have this time series of mean daily river flows. And our observations that are included in the file, in the zip file, start from January 1st, 1920, and they end at December 31st, 2009. And the data are expressed in cubic meters per second and are reported in the text file that you find in the zip file. Data observed on February 29th have been already removed. Okay? So, let's focus on the first question. Estimate the average flow duration curve by pulling all the observations together. This is the second method that we learned yesterday. Therefore, obtaining a high temporal resolution representation. Okay? It's not, the duration is not defined only for integer values of days, but also for intermediate values. So we pull all the data together. Okay, that's fine. Let's try to do it with that. Let's forget about the other questions for now. And we have here a first significant problem, which is putting the data into R. First of all, let's see what is the format of the data. So we have a second file, the zip. You can try to double click on it. Of course, your operating system will use a different program with respect to me to open the file. Sorry. Anyway, just 1 second. Here is how it looks, and you should get something very similar if you double click on it. This is a text file. Text file means that it's not written in any of the programs that we are used to apply for making our computation. It was not created with R, it was not created with Excel, it was created as a text via a text editor. It just suffices to know for us that the text file, the text format, it's a very, very simple format that can be read by any program. So you can upload it in Excel, you can upload it in R, you can upload it in whatever, in Word, whatever other program. It doesn't accept any format. In a text file, you cannot put bold, you cannot put underlined, etc. And again, it's readable by any program. So it's readable by R. If you want to open a text file from Excel, probably you can already do it. You already learned how to do it. You just have to click in Excel, open, and select the text file. And then Excel will ask you a series of questions like how do I have to read this file? They are numbers, they are dates, they are words. Excel wants to know from you some information and then uploads these numbers. Keep in mind that this is a very long series. You cannot just copy by hand because it's 365 times 90, so it's about 32,000 numbers. You cannot just type them. You have to find a way to upload it in the program. So Excel is easy. R is easy as well, but there are some technical issues that we need to resolve. It will take about 10 minutes, and I am optimistic to upload it for all of you. So the first thing that I suggest you is to save this file in an uncompressed format on the desktop. So you have to take the file from the zip and put it on the desktop. So if you double click on the zip will be opened by software that is used in your PC. You will be able to see the file ponte_po -ponte_txt, and if you drag the file from the zip to the desktop, you should be able to save it on the desktop. Good. Please do it, and let me know if you have any problem in dragging the file on the desktop. Unfortunately, I cannot display to you how to do it because I don't have Windows. Actually, I might find a way to do it, but let's try to move forward in this way. So may I know if somebody has problems to drag the file on the desktop? Raise your hand if you did not. Okay, I wait for a little bit. And then if you cannot solve the problem, I can try. Let me see. So it's where is the zip file? So it's here. Okay, just try to not to open it. Just a second. What I suggest is close it. Then what you have to do is just to click on it, but you have to keep the mouse pressed and drag it here. And I think it's now somewhere here. Okay, it's here. You see? Okay, so now just okay, so now it's here. So you have done. So what I did is just to drag it, and you have to keep pressing the mouse, and then you see copy the rest of it. Okay. Okay. Everybody. Yeah. Okay, but let's close it. This is Windows, or it's already here. I think it's okay. It's already here. No, it's fine. It's still a text file. Okay. Let me see. Yeah, I think it is okay. Don't be concerned if you don't see the numbers in columns so far. Okay, if there are problems, we will see later. Okay, and now we have the file on the desktop. So please click with the right on the file, and a menu will open. Click on Properties, Proprietà Italian, and if you click on Properties of the file, you will see that there is indicated the location, and the location it's a long string like C /user/desktop. Okay, please copy it. So I think you can copy it with the mouse, the location, or take a note on a paper. And please beware that the capital letters make a difference. So if you take note on a paper, just take note also of capital letters. What is the location? The location is the path of the file. It is the address on your hard disk where the file is located. It's like your street name, street number, and city. Basically, it's city, street name, street number. It's only missing the name of the file, like your address is missing your name. The location is extremely important because, again, it's the address of the file in your hard disk. We are basically, now, we are talking with the PC. It's different with respect to clicking on the file. Clicking on the file, we are just talking with Windows. If we want to tell to the PC, upload this file in R, we have to tell the PC where the file is located. The PC doesn't understand if we just say desktop or Windows. The PC says, what is Windows? I don't know. We have to know the location. Okay, this is important to explain to you because usually when you use Windows, you don't need to know the location of your desktop. You just use it. But indeed, for some applications, it is extremely important. Okay, now we can go to R. Let's go to R, to our console. Okay. And now let me write something like, let's define a vector which contains all the numbers, daily river flows of the Po River, like river flow.